In the heart of our galaxy, something is moving. Invisible, immense, and alive with power. For the first time, we've turned its motion into sound. NASA just released new black hole sounds captured from the James Webb Space Telescope. But these aren't just eerie cosmic melodies. They might reveal how the center of the Milky Way truly breathes. What you're about to hear isn't science fiction. It's the voice of gravity itself. Welcome back to Cosmic Atlas, where we explore the deepest mysteries of the universe, one discovery at a time. Today, we're venturing into a sound that technically shouldn't exist, because in space, there's no air, no medium, and no echo. Yet somehow, we've made the black hole sing. NASA's recent release features data from JWST, Chandra X-ray Observatory, and IXPE, transformed into audio form, a process called Sonification. But when these data were played back, something unexpected emerged. Rhythms, pulses, vibrations that seemed almost alive. So, what exactly did Webb detect? And are we really listening to the heartbeat of a black hole? Deep in the constellation Sagittarius lies Sagittarius A, a supermassive black hole, 4 million times the mass of the Sun, sitting at the center of the Milky Way. For decades, it appeared silent, shrouded in dust, flickering occasionally, but mostly calm. That illusion ended with the James Webb Space Telescope. Using its near-infrared camera, Webb peered through the gas and dust to reveal a restless, flickering storm. Over just 48 hours, the telescope recorded bursts of energy, flares that brightened and faded multiple times a day. Some lasted minutes, others seconds, like sparks leaping off an invisible inferno. Astronomers described it as a light show at the edge of time. What causes these flickers? They're not explosions in the traditional sense. They're magnetic reconnection events, massive, invisible lines of force snapping and reforming in the plasma swirling around the black hole. Each release of magnetic energy superheats gas to millions of degrees and emits light across the spectrum, from infrared to X-rays. And when that data is converted to sound, those flares become haunting crescendos, the cosmic equivalent of thunderclaps rolling through the void. Webb's infrared precision captured this chaos with detail we've never had before. Each flare's timing, brightness, and decay were mapped, and then played, like a symphony of gravity. So, how do we hear light? NASA's Sonification team converts telescope data into audio by assigning frequency, pitch, and volume to different wavelengths or brightness levels. Imagine the infrared glow of a flare as a deep note, the X-rays as a high-pitched hiss, and the brightness variations as rhythm. Combined, these create an auditory landscape, a translation of physical data into sound our ears can perceive. The result? A soundscape that rises and falls like breathing. Slow pulses of light become low, rumbling tones. Sudden flares become sharp bursts, percussion from the edge of a black hole. But here's the twist. Webb's data revealed patterns, not random noise, but quasi-periodic oscillations. The black hole's light flickers in measurable cycles like a cosmic heartbeat. Some scientists believe these oscillations could come from hotspots, clumps of plasma orbiting just outside the event horizon. Others think they're caused by gravitational lensing, light looping around the hole before escaping. In either case, we're seeing, and now hearing, the raw dynamics of gravity stretching light itself. When those patterns are turned into audio, the result is eerie. The sound rises, falls, and repeats. Not music, but motion made audible. It's as if the universe itself hums when matter crosses the point of no return. Webb isn't alone in this cosmic concert. The Chandra X-ray Observatory captured similar signals from the black hole in the Perseus galaxy cluster. In 2022, those data were also sonified. producing a haunting 57-octave below middle C drone, an actual pressure wave in intergalactic gas. Combined with Webb's infrared data, NASA scientists created layered audio of the universe, a remix of X-rays, visible light, and infrared. When you listen to them together, it feels like a choir of cosmic giants, each black hole contributing a note to a universal symphony. Here's the paradox. Space is silent. Sound, as we know it, can't travel through the vacuum between stars. So these sounds aren't literally heard in space. They're translations of energy, mathematical conversions of light or pressure data into the range of human hearing. But they do represent something real: movement, vibration, and interaction. In a sense, when we listen to these sonifications, we're hearing the mathematical truth of the universe, rendered as music. The bigger revelation isn't the sound itself, it's what it tells us. Sagittarius A is far more active than scientists expected. Flares erupt several times a day. Hot plasma dances just outside the event horizon. The magnetic fields twist, snap, and rebuild in mere minutes. This means our galaxy's core isn't a quiet grave. It's a living, breathing engine. Webb's observations are rewriting how we see our own galactic heart, not as a void, but as a beating core of light and gravity. As NASA continues to sonify the cosmos, we may soon hear other wonders: colliding galaxies, supernova remnants, even gravitational waves rendered as sound. Every data point Webb captures brings us closer to understanding not only what the universe looks like, but what it feels like. Because maybe, just maybe, the universe has always been singing, and we're only now learning to listen. This is Cosmic Atlas. Stay curious, stay infinite. Don't forget to like, subscribe, and share, so more people can hear the sound of the universe.